Okay, so here we have a definite integral that requires u-substitution. And we're going to do it two different ways. We'll begin with option 1, which is just ignoring the limits, at least at the start. Okay. So instead of making it a definite integral, let's treat it just like an indefinite integral. And let u equal 5x minus 2. Then du dx is equal to 5. Du will be 5 dx. And dx is going to be equal to du over 5. So that's one of the key parts, and that's the other. Okay, now if we do that, then we get the integral. Okay, it's going to be u cubed times dx is du over 5. So that's going to be 1/5 of the integral of u cubed du, which is 1/5. Now integrate of u to the 4 over 4. Now this is usually where we would say plus to add the plus c, but instead of adding the plus c, what we'll do is we'll leave it out because we're going to reintroduce the limits once we replace the u. Okay, so this is going to be 1 over 20. 5 times 4 gives you 20. U to the power of 4, that's 5x minus 2. 5x minus 2 to the power of 4. And it's going to be from 0 to 1. Okay, well, let's start putting in these numbers, and that's going to be 1 over 20 times 5 times 1 minus 2 all to the power of 4 minus 1 over 20 times 5 times 0 minus 2 to the power of 4. Okay, so we've replaced it with 1 and then we've replaced it with 0. That's going to give us 1/20th of 3 to the power of 4 minus 1/20th of a negative 2 to the power of 4. That will be 3 to the power of 4 is 81, so that's 81 over 20 minus negative 2 to the power of 4 is positive 16. So it's going to be minus positive 16 over 20. 6 from 11, and this is probably where I'll make a mistake, but 6 from 11 is 5. 2 from 8 is 60. 2 from 8 is 6. All over 20, well, that's going to be 3 and 5/20ths, or 3 and 1/4. Okay? So that's one method. That's option 1, ignoring the limits, gives us 3 and 1/4. Now we're going to move on and do the same problem, but with a completely different method. So we'll try it now with option 2. And option 2 is a method wherein we change the limits. Okay. Change the limits, and there is no replacement of x terms at the end. No replacement of x, let's say, at the end. Let's just tidy that up a little bit. No replacement of x at the end of the question. Okay, so again, just to recap, the integral here is 5x minus 2 cubed. 5x minus 2 cubed dx, and the original limits were from 0 to 1. Okay, so what we're going to do this in a couple of different steps. So we will let u be 5x minus 2, so So it starts off precisely the same way the last one did. dx is going to be 5. And du is equal to 5 dx. So dx is equal to du over 5. Okay, so that's one of our keys, and that's the other key. Now, what's new this time is we're going to change the limits. Okay? We're going to change the limits. Now, what we're going to use for changing the limits is this part here. U is equal to 5x minus 2. Okay, so we're going to use that. And what we do is we look at the top limit. And these limits here, if you look back over here at the original problem, these limits are the limits that are defined in terms of x. Okay, so when the variable is given in terms of x, the upper limit is 1, the top limit is 1, the bottom limit is 0. So I'm going to call those xt. So xt is equal to 1, and xb for the bottom limit. So xt for the top limit, xb for the bottom limit is equal to 0. Now, that would mean that in terms of u, the top limit is 5 times 1 minus 2, which is equal to 3. And the bottom limit in terms of u is 5 times 0 minus 2, which is equal to negative 2. Now, here is a key part. The original question in terms of x was the integral from 0 to 1 of 5x minus 2 cubed dx. We're going to say that that's now equivalent. Okay, the bottom limit is minus 2, the top limit is now 3, and instead of 5x minus 2, we're going to call that u, and it's going to be u cubed, because it was 5x minus 2 cubed, so this is u cubed. And it's going to be times, we're going to replace the dx with du over 5. Okay. Now, this can be asked in the exam to give a u expression, a u integral, an integral defined in terms of u that's equivalent to this. So that's why we need to be able to do these problems this second way. Okay? It can be asked, these problems can be asked to give this particular form as the challenge. Rather than solve the integral, this is what they're looking for sometimes. So that's why we need to be able to do it this way, as well as the simpler way above. Okay, so now we're going to, let's pull out the 1/5. So it's going to be the integral from negative 2 to 3 of u cubed du, which is 1/5 of u to the power of 4 over 4, and we have limits, so it's going to be from negative 2 to 3. Okay, and that's going to be it's going to be 1/20th, 5 times 4 is 20th, of 3 to the power of 4 minus 1/20th, again, beg your pardon, minus 1/20th of negative 2 to the power of 4. Okay, so if there is any advantage, it's that we don't have to go back to x's. As long as we change the limits, we can integrate in terms of u and substitute in the limits for u. We don't need to go back to x here. So this is going to give you 3 to the 4 is 81 over 20, minus negative 2 to the 4 is 16, so it's going to be positive 16 over 20, so minus positive 16 is minus 16 over 20. Same expression as before. What did we say that was? It was 65, was it? 65 over 20 is 3 1/4. So you get the same answer each way. In fairness here, if we look at the relative sizes, that's option 2. That's option 1. Okay, so they tick. Option 1 is maybe a little bit shorter, quicker, but certainly option 2, in certain circumstances, is the way that you might want to go. And you definitely need to know both both approaches. Okay, so hopefully that helped, and take your time with this. Is a long exercise. Okay, thanks for watching and putting up with it.